Suppose that the heights of world-class runners are normally distributed with an average of 100 centimeters and a standard deviation of 8 centimeters. Consider a random selection of 50 world-class runners. Number 1. Would you be surprised if the average height of the 50 world-class runners were greater than 185 centimeters? Explain. To answer question 1, we need to first decide what the distribution of the averages is. We're being asked for information about the average height of 50 runners. So the average, the distribution of the averages is normal with a mean equal to the mean of the underlying distribution, 180, and a standard error equal to the standard deviation of the underlying distribution divided by the square root of the sample size. So we want to find out if it would be surprising whether the average height of 50 world-class runners were greater than 185. So let's calculate probability. If it's very likely, then we won't be surprised. If it's not likely, then we will be surprised. So we want the probability that x bar, the average, is greater than 185. So that's 1 minus normal. 180, 8 divided by the square root of 5, and 185. So we'll have to ask GeoGebra what that number is, but that's how we're going to find it. 1 minus normal, mean of 180, standard deviation 8 divided by the square root of 50, and 185. Yeah, that's not very big. Let's see, 1, 2, 3, 4, 5 zeros, 4, 9. 5 zeros. So this is approximately 1, 2, 3, 4, 5, 4, 9. So yes, we should be very surprised. So yes, this is not likely to happen. Yes, we would be surprised because this is not at all likely. The probability is just too small. Number 2. Which is more likely? The height of a single randomly selected runner being greater than 175, or the average height of 50 selected runners being greater than 175? Well, x, the underlying distribution, was also normal. It says it's normal. Normally distributed with an average of 180 and a standard deviation of 8. So we want to compare the probability. So we want to compare the probability of x being greater than 175 to the probability of x bar being greater than 175. So that's this one, the average height greater than 175 and the height of a single person being greater than 175. And we know they're both normally distributed, so we can make a quick sketch here and figure this out without actually calculating. So we don't have to go to GeoGebra for this one. So let's not. We'll just draw a couple of pictures and this thing will be solved. Okay. So the averages are 180 on both diagrams. The difference is in the standard error, standard deviation. For x, the standard deviation is 8, and for x bar, the standard deviation is 8 divided by the square root of 50, which is just a little bit more than 1. So we'll call it 1 for purpose of our diagram. That's close enough. So over here, 1 standard deviation is going to be right about there. So that's 172. And therefore 175 is right around here. And the probability that x is greater than 175 is this shaded area. Over here, we have to, again, look for 1 standard deviation is going to be right about here. And we said 1 standard deviation is somewhere around 1, so that's close enough. And we need to get down to 175 because we want the probability x greater than 175. So 1, this is 179, 178, 177, 176, 175 is way over here where the normal graph really should be essentially touching the axis. In any case, if we shade everything to the right of 175, that's essentially the whole thing. So this is about 1, almost guaranteed that probability will be 1, whereas this one is something less than 1 for sure, because the shaded area is significantly less than 1 because we have this unshaded part. So the answer is, to the question of which one is more likely, the average. The average is more likely.